We're looking at 8C.2. We're now finding the length of an arc by setting up a proportion comparing the arc to the circumference of a circle. So the first thing we're going to do is two of our words are just review. So first, the circumference. We learned that in B1. Remember, the circumference is just the length around the circle. Remember, circumference equals 2 pi times r. Okay, we're going to need to use that. Remember, arc measure. All right, so now we're looking at two different words here, arc measure and arc length. These are not the same thing. Okay, arc measure is the angle measure of the arc. So arc measure is the angle measure of the arc, and it uses degrees as units. Right? Right? So whatever the measure of this arc is the same as that central angle. Right? So if this is 30 degrees, then this is 30 degrees. Okay? Then finally with this one, our arc length is the length of the arc. It can use feet, inches, centimeters, etc. Right? Meters, kilometers, I don't know, other units of measurement, miles, why not? Right, anything that's measuring length, okay, versus an angle. Okay. So how do we find arc length? So really all we're doing is we're going back to what we did in KC6. We are setting up a proportion. I'm going to compare the piece of my circle to the whole of my circle. And what I mean by that is this arc length is just a piece of the circle, right? And the central angle is just a piece of the circle. Okay, so the piece over piece is going to equal the whole over the whole. So I'm going to look at circumference. And again, the circumference, right, is 2 pi times r. It's that whole part around the circle divided by the measure of the whole circle. And that's just always going to be 360 degrees or 2 pi. Right, if I look at the whole angle measurement of a circle. Okay, so let's look at an example. Example 1, find the length of the darkened arc. Okay. So my x is out here. This is what I'm looking for. Okay, so that uses an angle of 315 degrees. The length around the whole circle is the circumference. Remember, circumference equals 2 pi r. So 2 pi times 11 is my r. Right? That's my radius there. Divided by, if I'm looking at the whole circle is 360 degrees. Okay, so you're just setting up that proportion. Once we set up that proportion, it's just like every other time we've set up a proportion. We're just going to solve. So I have 360 times x equals 315 times 2 pi times 11. Okay, so this is going to give me 360x equals When I multiply 315 times 2 times 11, again, I'm not going to type in my pi. I get 6,930. Then I'm going to divide, right? To solve for x, I just need to get rid of the 360. Ooh, sorry, I forgot the pi. 6,930 pi divided by 360, x equals 6,930 divided by 360 is 77/4. And then don't forget the pi. So just like we were writing the radians. And this is in feet. Okay, looking at example 2. Pretty much the same exact problem, except now we are looking at one that's in radians instead of degrees. That's only going to change one small part of our problem. But it's still going to start the same way. I am still looking for my, this arc. How long that is. So I have x over the angle. Just now my angle, instead of a nice degree, is 3 pi over 2, right, in radians. Equals. So then I need my circumference. Again, remember, my circumference is still 2 pi times r. I don't know what that mark is. 2 pi times r is 16 here. Over, now my whole circle, I'm not going to say 360 degrees. I'm going to say 2 pi. Alright, so that's the only thing that changes when you're in degrees versus radians, right? That whole circle. So then I cross multiply, so I have 2 pi times x equals 3 pi over 2 times 2 pi times 16. So I have 2 pi x. Oops. Sorry about that. Equals. Again, I'm going to kind of ignore my pi's for right now. I'm going to multiply everything else. So I have 3 halves times 2 times 16. Okay. And that gives me 48. And then how I'm just going to write is I have a pi here and a pi here, right? I have 2 pi's coming in. Then, right, whatever is being multiplied by x, I just divide. (48) divided by 2 is 24. Then one of my pi's cancel out, and I am left with a pi. So 24 pi v. Okay, so be careful when you are in radians because your pi's kind of get discombobulated, right? There's a lot of pi's floating around. Just know you should still end up with 1 pi in your answer. All right, let's look at the last example. In circle J, KM is a diameter with length of 24 centimeters. And the measure of angle KJ, what happened? That should be KJL, is 120 degrees. I believe yours still says all that. I don't know where my L went. Equals 120 degrees. So the first thing I'm going to do is draw a circle K, or circle J. Okay. Then KM is a diameter. So my diameter goes all the way across. That whole length across is 24. And then there's an angle, K to J to some letter L. I don't where it is, right? That's 120 degrees. Okay. So I've already done A. So B, find the length. The one thing I have to do is, right, I don't really want my diameter, right? The diameter is 24. So again, that's diameter equals 24. So radius equals 24 divided by 2, which is 12. So don't forget that, again, just like in our volume ones, if we're given the diameter, we really need to find our radius. Done. Now I can find the length of that arc. So now it's just like what we did before. I'm finding the length of this arc, x, over my angle, which is 120 degrees, is going to equal the whole circumference of my circle. Circumference again is 2 pi times r. R I know is 12 over my whole circle, which is 360 degrees. Okay. Cross multiplying, I have 360 times x equals 120 times 2 pi times 12. So that gives me 360x equals, I need to do 120 times 2 times 12. And I get 2,880. And don't want to forget my pi. And then I need to divide by 360 on both sides. Ah, that's not my calculator. Divide by 360 and I get 8. It's a nice number. Oh. 8 pi, and my unit here is centimeters. That's it for C2. Okay. Go ahead, work.